Hello everyone. So, we have already covered the historical background related to EV development in our previous interaction. Let us begin the discussion on the next topic under Introduction to EV, which is benefits of using EV compared to other modes of transport. So, the big question is why EVs? It seems that the global population, which is 6 billion currently, if it increases with the current trend, may become 10 billions by 2050. So, what that means? It means the vehicles in use may increase from 700 millions, which was there in 2000, to 2.5 billions by 2050. And if all these vehicles are IC engine based vehicles, then most likely all the cities will be covered with permanent smoke with extreme air pollution, and this is very drastic in terms of health. According to one of the reports of ARB, which is Air Research Board, which came in 2011, around 9,000 people die every year in California due to fine particulate matters. So, these numbers are alarming and there is a necessity to think ahead. So, what is the way out? One of the promising solutions is sustainable transport. So, what is sustainable transport? It means use of low or zero emission vehicles, promotion of public transport so that very less vehicles will be on the road, use of more and more renewable energy sources for charging these zero emission vehicles. It also means we will be less dependent on fossil fuels, which is a large source of air pollution. So, to better understand the advantages and shortcomings of EV, let us compare the EVs with other modes of transport. The comparison can be done on following parameters: energy sources, pollution, energy diversification, efficiencies, capital and operating cost, and performance. Now, let us compare the different types of energy sources used in different types of vehicles. We all know gasoline, which is petrol, diesel, compressed natural gas, which is CNG, hydrogen, batteries, and the upcoming ultra capacitors and ultra flywheels. So, petrol and diesel are liquid fuels, while CNG and hydrogen are gaseous fuels. Battery stores the energy in chemical form and provides energy in electrical form. Ultra capacitors stores the energy in electrostatic form, while ultra flywheel stores the energy in mechanical form. Both petrol and diesel have similar energy content per unit mass, which means they have same specific energy. But since diesel is more denser compared to petrol, it has higher energy content per unit volume. The energy per unit volume is also known as energy density. By having higher energy density, the diesel is more fuel economical compared to petrol. The CNG has higher specific energy compared to liquid fuels, but it has very low energy density. On the other hand, hydrogen requires storage at a very high compressed state by using high pressure, and therefore, it requires lot of ancillaries around its fuel tank. But on the positive side, it has very high energy density compared to petrol, diesel and CNG. Therefore, there is a serious effort to make hydrogen based fuel cell electric vehicles a commercial viability. Batteries, if you take a recent battery example, let us say lithium ion battery, the lithium ion battery has specific energy and energy density very low, around 75 times low and 25 times low compared to petrol, which means that for the same energy content, the mass of lithium ion battery will be 75 times more compared to a petrol, and it requires 25 times more volume compared to petrol. This is a serious limitation of batteries compared to liquid fuels. Ultracapacitors provides very high specific power, but it can store very limited energy. As we know, ultra flywheel stores energy in mechanical form at very high speeds, but it has drawbacks such as it is less reliable and there is a safety concern around it when it is used inside the electric vehicle. There are various types of pollutants and greenhouse gases which are released as emission from vehicles, and they are the reasons for smoke and air pollution. So, some of them are particulate matter, which is known as PMX, carbon monoxide and carbon dioxide, CH4 which is methane, NOx gases which is N2O, NO and NO2, VOC which is volatile organic compounds, total hydrocarbons, and SOx gases which is sulfur dioxide. Particulate matter are particles released as a part of combustion cycle. These particles are extremely small in the range of micrometers. Therefore, they cannot be filtered by human throat and nose, and therefore, it enters the body and affect heart, lungs and brain. These particulate matters are cancerous in nature and one of the major reasons for causing cancer due to air pollution. Diesel engine release more PM compared to petrol. PM particles less than 10 micrometer, which is PM10, are very dangerous and if inhaled can cause severe damage. So, these are clubbed and referred as PM 2.5. These three gases are known as greenhouse gases. Due to the presence of these gases, the infrared radiations are trapped in the atmosphere. Due to the presence of these gases, the infrared radiations will be trapped in the atmosphere and cause greenhouse effect such as climate change and global warming. Carbon monoxide is a colorless, odorless gas which is very dangerous for human health. It is highly poisonous. Large amount of CO2 is released by IC engine based vehicles, which adds to the already present CO2 in the atmosphere and thus contributes to greenhouse effect. NOx gases, VOC and total hydrocarbons are responsible for building ground level ozone layer. So, the ozone layer, if it is present in the ground level, is very dangerous for humans. It can create lining in the lungs and cause major respiratory illnesses such as asthma and lung inflammation. So, diesel engine are the main source of NOx gases. So, these gases can be filtered using catalytic converter, but these devices are costly. So, NOx gases can be minimized by use of urea filters. So, SOx gases, which is dominantly SO2, sulfur dioxide gas, is released by coal based thermal power plants. So, we can say that if electricity is used in EVs, they are creating more SOx gases in the atmosphere. So, the sulfur dioxide gas reacts with oxygen and water present in the atmosphere and creates sulfuric acid in the atmosphere. So, these are the major reasons for acidic rains. The solution is low sulfur coal should be used for power generation, which is costly of course. So, let us have a quick look at the graph of relative emissions caused by various pollutants with respect to type of EVs. So, it can be clearly seen that the harmonic emissions by the use of battery electric vehicle is comparatively very small as generated by IC engine based vehicles. The emissions by hybrid vehicles lies somewhere in between these two extremes. So, the global countries are pushing for hard regulations. We all know about Euro regulations in Europe and Bharat stage regulation in India, which is enabling vehicle manufacturers to do research such that the emission of these pollutants can be minimized. So, it is interesting to compare energy diversification of different types of vehicles. IC engine vehicles typically use liquid fuels and gaseous fuels, which are coming from either oil or natural gas. While pure electric vehicle such as battery electric vehicle and fuel cell electric vehicle use either electricity or hydrogen as energy carriers. So, if we see the types of fuels and the sources which are required to generate these fuels, we can clearly see that electricity can be generated by almost all the energy sources. Therefore, EVs have a definite advantage compared to IC engine, which requires oil and natural gas as its fuel. So, among different types of vehicles, PHEV you can say most energy diversified, because it can run on both liquid fuels and electricity, and these two fuel sources have an already excellent infrastructure support present now. The use of EV also provides higher energy efficiency. So, if we compare fuel tank to vehicle efficiency, the battery electric vehicles provides 72% efficiency at the wheels, and the fuel cell in the IC engine vehicles provide 40% and 16% efficiency at the wheels if we take the starting source as 100%. A more fair comparison can be done if we start from the source of energy, which is let us say crude oil. So, if we start with 100% crude oil for both battery electric vehicle and IC engine vehicle, we can see that the efficiency on the wheels is 18% for battery electric vehicle and 13% for the IC engine based vehicles. The major loss in calculation of battery electric vehicle efficiency happens in power generation. It is only 36% for a typical thermal power plant, while the major loss component in the efficiency of IC engine based vehicle is very inefficient engine efficiency, which is only 20%. So, the overall efficiencies of battery electric vehicle and IC engine based vehicles are comparable, but battery electric vehicle have few advantages such that energy can be recovered during braking as regenerative power. Secondly, it can be charged using renewable power, which is pollutant free. So, let us compare EVs with ICEV in terms of capital cost and performance. So, battery electric vehicle have higher fuel economy compared to IC engine based vehicles, but they are more expensive because of higher initial battery cost and the requirement of battery replacement after few years. The BEV requires less maintenance, is more reliable. As we mentioned, it can recover energy during braking. It is also less noisy. Battery electric vehicle also allows high performance control. On the negative side, BEV requires continuous charging and they have a limited range per charge. So, this is a cause of concern and it causes range anxiety among customers. BEV can be charged using renewable energy sources such as solar. Also, for the same energy requirement, BEV requires more space and is more heavy. So, we will begin our next topic of discussion, which is overview of different types of EVs and their challenges in the next interaction. Thank you.